Hi everyone. Okay, here's video number 2. Would you believe it? I was sitting here, what was about 6 hours ago, and it was sunny and it was beautiful outside, and now it's pouring with rain. So yeah, welcome to Melbourne weather. Anyway, let's get stuck into this. Hopefully it won't go for 30 minutes like the other one. So the other video is focusing on questions. Well, I wrote questions 1 to 5, but it was questions 1 to 4, and this one's going to be question 5 onwards. All right, so for each of the following, state the features of the parabola and then sketch the parabola. All right, so it's very important that we look at the form that the quadratic is in. Okay, so this is in factorized form. So this means we can see straight away what the x-intercepts are. So your x-intercepts, and I know I'm going to be doing this one first, and we've got a bit of space below. So let's, no, we don't, not much space below. All right, so when we're doing your x-intercepts, we're going to let y equal 0. And I might just make that a bit bigger because it's a bit hard to write so small. There we go. So with our equation, what was it again? X plus 3, x minus 3. So we're going to have x plus 3 is equal to 0. And x minus 3 is equal to 0. We probably don't need brackets, so let's get rid of them. All right, and that's the null factor law, which we covered in detail when we did quadratics. So that means x is equal to -3 and x is equal to 3. So they're our x-intercepts. Now, when you're writing any points, you should do the full coordinate. So we're going to have 3, 0 and -3, 0. So we've got 2 x-intercepts. Now for your y-intercept, we let x equal 0. Let's do that down here. So y-intercept, let x equal 0. So we're going to have y equals 0. Can't remember what the first one was, but I remember one was -3 and one was 3. So 3 times -3 is -9. So your y-intercept is at 0, -9. Now your turning point is halfway between your x-intercepts. So if I go ahead and put them on, so there we've got -3 and there's 3. You can do it wider. It doesn't mean like each line doesn't have to necessarily be 1. And then we're at -9 down here. And I've actually also just drawn the turning point, not on purpose, but let's just pretend that that point, we haven't put that on yet. Okay, so if you were doing it with any factorized quadratic, your turning point or your x coordinate of the turning point is halfway between your x-intercepts because a parabola is symmetrical. So for your turning point, all we do is add our x-intercepts together. All right, so 3 plus -3 divided by 2, because we want to find the average of the two. Now, obviously, 3 plus -3 is 0. So that's why your turning point is at 0. And if I substitute that in, which I did do here anyway, that's going to be your turning point. So your y-intercept and your turning point are actually the same. All right, so let's go back up here. So your turning point is also at 0, -9. And your axis of symmetry is just, you're splitting your parabola in half, so it's symmetrical on both sides, and that's along the line x equals 0. So whatever the x coordinate of the turning point is, that's going to be your axis of symmetry. So now parabolas are really hard to draw, especially for the first time. Actually, they're not hard to draw, but they're hard. Oh, she says that she does a very wonky parabola, so maybe we'll do that one again. Doing the parabola for the first time, or when you're starting to learn, it can actually be quite difficult. So just remember they are curved. You don't want to go like something like that, and they do have to be curved in nature. So having the points does help, and just going maybe from point to point, as opposed to drawing the whole thing at once. And always draw your graphs in pencil, right? Trust me. If you make a mistake in pen, and you've only got one grid, it's like, oh my gosh, how, it's just going to be a bunch of scribble. So if you do it in pencil, at least you can rub it out. All right, moving on to the next one. All right, so this one here is in turning point form. Now your y-intercept is when x equals 0 and your x-intercept is when y equals 0. The turning point, however, we can see straight from the quadratic because it's in turning point form. So that's 3, 6. And remember, your axis of symmetry is just x equals whatever the x coordinate is of your turning point. So in this case, it's x equals 3. All right, let's do the, what do we do first? Let's do the y-intercept. So y-intercept, let x equal 0. So we're going to have y equals negative 0 minus 3 squared. Oops, close that bracket, sorry. Plus, oh gosh, making lots of mistakes. Should be a plus. All right, so let's just tidy it up. Y equals, so negative 3 squared is 9, but we do have that negative out the front. So y equals negative 3. So your y-intercept is at 0, negative 3. And x-intercepts, remember, you can have 3 scenarios. You can have 2 x-intercepts, which we often see. You can have no x-intercepts. So that just means it doesn't cross the x-axis, or it can have 1. That means it sits on the x-axis. Now for this one, I know it has x-intercepts because it's a negative parabola. So I might just unhighlight that. Negative because we've got a negative out the front, and it shifted up 6. So I know it's got x-intercepts, so we can keep going. All right, so when we're finding the x-intercepts, we let y equal 0, and this is the annoying thing about making it so big, we don't, negative x minus 3 plus, so x minus 3 squared plus 6 equals 0. Whoops, there's a negative there. So we're going to have x minus, all right, I'm going to do a few things in one step. So I'm going to take that 6 over. Now, actually, no, I won't, because I might be doing too many things at once with you guys. All right, see how we've got both a negative and a negative on both sides? So we can just then go ahead and make them both positive. I'm running out of room here. All right, here I'm going to do 2 steps. So we're going to see that as a positive 6 and also get rid of that square root sign. So sorry, the squared sign. So to get rid of the squared sign, we take the square root of both sides. So x is equal to square root of 6 plus 3, and x is equal to negative root 6 plus 3. All right, so when you've got it in turning point form, unless your constant here outside the bracket is a perfect square, you're going to end up with a third. But you know, that's okay, because not everything can be nice and exact. So our x-intercepts, I was about to write x. All right, our first point, doesn't matter what order you do it in, root 6 plus 3, 0. So that's the first coordinate. And then we've got negative root 6 plus 3, 0. All right, now when you're sketching it, we need to put all those points on. So your y-intercept is at negative 3. So I'll put that on. There it is at negative 3. I'm just trying to think of the best side to put that on. Your turning point is at 3, 6. And our axis of symmetry, doesn't matter about that. All right, so your x-intercepts, because you're dealing with surds and you're not going to have your calculator, you kind of have to know approximately what it is. Now, the square root of 6 is somewhere between the square root of 4 and the square root of 9. All right, so the 2 perfect squares either side. So it's somewhere between 2 and 3. All right, does that make sense? So I'm asking you a question as if you can answer, like, you know, what show was it? And they would always talk, maybe Dora. You guys are probably a Dora generation. But Yep, so the square root of 4 is 2, then the square root of 9 is 3. So the square root of 6 is going to be 2 point something. So 2 point something plus 3, or negative 2 point something plus 3. So we're going to be, you know, somewhere, I don't know, around here. We've got to be symmetrical. Now, it doesn't really matter if you're not exact, because I would be so, oh God, that's a terrible parabola. I'd be so excited if you just got those x-intercepts. So what have we got? Root 6 plus 3 comma 0. That's the first one. And then this one here is negative root 6 plus 3 comma 0. All right, and that's a terrible parabola, but if you drew it like that, I would be pretty happy, okay? But I have high expectations because I've been drawing parabolas for a very long time. All right, the next one. All right, another parabola. So this one here is in expanded form. Now, when I look at this, I first of all notice this 2, and I notice that 2 is also a common factor. So I'm going to take that out as a common factor. What do we got? 5x plus 6. And then I think, okay, can I factorize that? Can I find two numbers that multiply to give me 6 and add to give me 5? Yes, I can. We're going to have x plus 3, x plus 2. All right, so now it's in factorized form. Now my y-intercept, when it's expanded, is always going to be your constant, or you can just let x equal 0. So 0, 12, your y-intercepts. Now this 2 at the front, it doesn't make any difference. So they're going to be at negative 3, 0, negative 2, 0. Your turning point, remember, is halfway between negative 3 and negative 2. Oh my gosh, why did I do such a hard one? All right, well, halfway between negative 2 and negative 3 is negative 2.5. Oh my gosh. All right, it's okay, we can deal with it. Obviously on your test, you're not going to get one this hard. All right, so your turning point is at x equals negative, what was it, 2.5? So as a fraction, it's 5 on 2. I'm just doing it as a fraction because fractions are a lot easier to deal with. All right, so to get the y coordinate, we just got to substitute that negative 5 on 2 into our quadratic. So you can do either the expanded or the factorized. Now I'm kind of feeling factorized is going to be easier. So just substituting x in. All right, so into this one here. All right, negative 5 on 2 plus 3. Now I'm going to rewrite that 3 as 6 on 2 just so we can deal with the same fraction. And then negative 5 on 2 plus 4 on 2. Okay, so let's tidy that up. This is where it's really important to have fractions. Now, obviously in year 10, you probably wouldn't get one this challenging, but you definitely will in method. So it's really important that you can deal with fractions. All right, so we've got negative 5 on 2 plus 6 on 2, so that's going to be a half. And then negative 5 on 2 plus 4 on 2, that's negative a half. All right, so we've got 2 times a half times negative a half is negative a quarter. And that is going to be negative 2 on 4, which is negative a half. All right, so your turning point is negative 5 on 2, negative a half. And your axis of symmetry is just not that. It's x equals negative 5 on 2. All right, so let's plot those points. So we've got a y-intercept at 0, 12, which is going to be all the way down here. Negative 3, negative 2. Now I kind of feel like I may have made a mistake somewhere. Negative. All right, I'm just... Oh, no. I have... Okay, I'm going to pause because I've made a mistake somewhere. Oh my gosh, this is such an obvious one. How did I even do that? It is not 12 down there, that's negative 12. I can't believe I did that. All right. Let's put it in the right spot. That makes so much more sense. All right, now I'm going to make these a bit wider because I don't like them. So I'm going to make this, where can I do it? All right, let's do 1, 2, 3. That doesn't make much difference. All right, I'm going to make them really wide. It's probably not the best way to do it. And that's negative, negative, negative 3. All right, just so we can have a wider x-intercepts. And then, yeah, so that's going to be pretty close to the x-axis. Oh, this probably, oh, that is terrible. Yeah, so not the best one. I actually just drew it quickly on Desmos before so we could see. So that's how I knew that my y-intercept was wrong. So it looks so much better here. But there we go. If I made it a bit narrower, it's a bit hard to, probably would have been too hard to draw. But you can see there the features. There's our, whoops, get back on there. There's our turning point and our 2 x-intercepts, and there's our y-intercept. So I changed the scale a bit to make it a bit wider, but maybe I should have left it how it was. Anyway, it doesn't matter. I've got the key features on there, and technically what I've drawn is not wrong. Just doesn't look too good. And I probably should label that turning point as well. So -5 on 2, -1/2. All right, let's move on to the next one. So again, we've got turning point form. All right, which is nice. So we can see straight away what our turning point is. That's at -3, 2. So the 2 out the front of the bracket doesn't make any difference to your turning point. Your axis of symmetry is at x equals -3. Now your y-intercepts will work out in a second. Now your x-intercepts. Now I know this is a positive parabola that's shifted up 2. So there isn't going to be any. So there's none. Now let's say you know, because you're still learning, you might not notice that. So what you would do, you will notice it pretty soon. So remember your x-intercepts, we let y equal 0. So if I let that equal 0, what is it? 2x plus 3 squared plus 2 equals 0. All right, so let's just quickly go through this. All right, so I'm going to divide both sides by 2. And when I go to get rid of that squared by taking the square root of both sides, this is why you don't have x-intercepts, because we get no real solutions when we take the square root of a negative number. So even if you didn't notice that there were no x-intercepts straight away, when you go to solve for x-intercepts, you'll soon notice that there are none. All right, and then your y-intercept, we just let x equal 0. So what's that going to be? 3 squared is 9. 2 times 9 is 18. Oh my God, at 20. Thank you. Thank you for giving me a high one. And I'm not even going to bother rewriting that in pink. All right, so we've got no x-intercepts. We've got a turning point at -3, 2. So there's -3 going up 2. And I'm just going to call that 20 there. And remember, it's symmetrical, so we're also going to go through that point if you need another point. The reason I chose that point, we've gone with 3 across either side of your axis of symmetry. So this is, if you wanted to draw your axis of symmetry, just this dotted line. So we're going 1, 2, 3 that side, 1, 2, 3 that side. All right, I'm going to get rid of that because it's going to make my parabola look really weird. All right, and then the other side. Oh, that's not a bad parabola. If you wanted to put the coordinates of this other point on, what is that? 6, 20. All right. I think this is our last one. All right, question 6. Oh, how many? 3. State the equation of the following parabolas in factorized form. It should be factorized. Duh. form. All right, so we can see our x-intercepts, which is awesome. So we're going to have a times x plus 2, x minus 4, and then we just substitute in another point to get the value of a. So you can do either 0, -8 or 1, -9. Now I'm going to do 0, -8. So we've got -8 equals a. 0 plus 2 is 2. 0 minus 4 is -4. So -8 equals a times -8. Divide both sides by -8. They cancel and a is equal to 1. So your equation in factorized form, a is 1, so I don't need to write 1. Now I'm going to also do it in turning point form. I know it doesn't say to, but I'm going to show you anyway. All right, so we've got y equals a. Now your value of h is your turning point, so x minus 1 squared plus k, so minus 9. And we're again finding a. So you can substitute any point that you haven't already used. So obviously we've already used our turning point. So you can use your y-intercept or you can use either of the x-intercepts. I'm going to go ahead and, I don't know what I'm going to use. Let's use the y-intercept again because letting y equals 0 is pretty easy. -8. Actually, no, I'm going to do, because I'm just going to get a big number. Let's do 4, 0. 4 minus 1 squared minus 9. 4 minus 1 is 3. 3 squared is 9, so we end up with 9a minus 9. So 9 equals 9a. Divide both sides by 9. They cancel out, and again we get a equals 1. So if we're going to substitute that back in, x minus 1 squared minus 9. So you can see here it's factorized form and this is turning point form, but they're both the same thing. If you wanted expanded form, then you just go ahead and expand the either quadratic. All right, doing the second one. All right, I'm just thinking if we've got enough points. Now we probably don't have enough points on here, but we can see that this point here is going to be, what was it? So it's going to be 2, not 2, 0, 2, 2. Now the reason I know that is because I've just read it straight off the axes. So our turning point is at 1. All right, so if we go across one more, we're going to be at 2, and there we go. It's also at y equals 2. All right, so you can use either factorized form. If we're doing factorized form, remember you've got a repeated factor at x minus 1. Actually, we probably didn't need, yeah, just thinking we probably didn't need that. All right, because it's a repeated factor, it's x minus 1 squared, and then you just need to find your value of a. So we didn't really need to get that other point. All right, y equals 2, 0 minus 1 squared. So 1 or -1 squared is 1, so a is equal to 2. So our equation is 2x minus 1 squared. Now that is both in factorized form and in turning point form. And you can kind of see that the quadratic x squared has shifted across 1. All right, it hasn't been shifted up or down, it's just gone across 1, and it's also been dilated. All right, last one. Okay, so again, we've got our, oops, what are you doing? Oh gosh, what is it doing to me? Do not know. I wonder if it, this is going to get annoying. Don't think it, are you right now? No. Do you want to be in pink? No. It's going to let me, there we go, okay. Let's just hope it gets to the end. All right, substitute in a point. So we're going to substitute in 0, 12.5. All right, so when we substitute x equals 0, we're going to have 5 times -5, which is -25, and then divide both sides by -25. So a is equal to -1/2. So we're going to have -1/2, x plus 5, x minus 5. And that's in factorized form. If you wanted to do turning point form, all right, so your value of h is 0. So this is going to be x squared plus 12.5. Whoops. All right, and then you'll substitute in a point. So you can do either 50 or -50. You get an a value of -1/2. I'm just going to cheat. There we go, 12.5. All right, so I'm just curious. I did a question earlier and I said there were no solutions, and now I'm like a little bit conscious that there may have been enough information. X squared, no. So we still couldn't do D. I'm just trying to think. Passes through the origin. Yeah, so it doesn't say that. Now, if there was a turning point at the origin, we could do this one, but it passes through the origin and the point to 8. So yeah, again, still not enough information. All right, I'll leave it there, just under 30 minutes. Yeah, bye girls.